Welcome to today's ArXiv Computer Science Digest for June 2nd, 2026. We received 974 new computer science papers today across 55 subfields. Let's dive into the top picks. Trend 1 of 10, Efficient LLM and Speech Processing. Advancing efficient large language models and speech processing through novel architectures, training, and adaptation techniques. This cluster covers 131 papers. Representative work includes Language Models Need Sleep. Learning to self-modify and consolidate memories. Train once, reuse everywhere. Generalizable implicit in-context learning by routing attention, and Align ATT for LLM. Fast Align ATT for decoder-only LLMs at IWSLT 2026 Simultaneous Speech Translation Task. Trend 2 of 10, Physics-Informed and Novel ML Models. This trend explores innovative machine learning architectures and methodologies, often integrating physical principles to solve complex problems. This cluster covers 77 papers. Representative work includes Discrete RDC. Discrete diffusion policies are natural asynchronous executors, correcting neural operator spectral bias via diffusion posterior sampling with sparse observations, and physics-informed single-atom matching pursuit, guided waves wave numbers, and propagation distance estimation for damage localization in structural health monitoring. Trend 3 of 10, AI security and adversarial threats. This trend explores adversarial attacks, vulnerabilities, and security challenges in AI systems, especially large language models. This cluster covers 63 papers. Representative work includes Position. Adversarial ML for LLMs is not making any progress, backdooring mass diffusion language models, and SAIL, sound abstract interpreters with LLMs. Trend 4 of 10, Robotics, Embodied AI and Control. Developing intelligent, embodied systems for perception, control, and interaction in physical environments. This cluster covers 87 papers. Representative work includes PixVOD, Pixel Distributed Direct Visual Odometry and Depth Estimation, Self-Refining Agentic Reinforcement Learning for Vision Condition UAV Navigation, and VLISA, Vision Language Embodied Safety Agent for Human Activity Monitoring. Trend 5 of 10, Neural Network Learning and Optimization. Focuses on advancing neural network learning algorithms, architectures, and optimization techniques for improved performance and understanding. This cluster covers 80 papers. Representative work includes Using Reward Uncertainty to Induce Diverse Behavior in Reinforcement Learning. Quadratic integrate and fire neurons exhibit less fragmented loss landscapes and outperform leaky integrate and fire neurons in spike-based gradient descent and neural network verification using partial multi-neuron relaxation. Trend 6 of 10, LLM Reasoning, Evaluation and Control. This trend explores methods to enhance, assess, and guide the reasoning capabilities of large language models. This cluster covers 128 papers. Representative work includes NewtPhys, Do Foundation Models Understand Newtonian Physics? SkillRM, Unifying Heterogeneous Evaluation Criteria via Agent Skill, and Quantifying Faithful Confidence Expression in Large Reasoning Models. Trend 7 of 10, 3D Vision and Multimodal Generation. Advancing 3D Scene Understanding and Generation, integrating diverse modalities for richer, more interactive AI systems. This cluster covers 166 papers. Representative work includes Exploring Easy Boosts for LiDAR Semantic Scene Completion, SIMU Scene, Simulation-Ready Compositional 3D Scene Reconstruction from a Single Image, and Imaginative Perception Tokens enhance spatial reasoning in multimodal language models. Trend 8 of 10, Formal AI and Agent Optimization. This trend explores rigorous methods for designing, analyzing, and optimizing AI agents and their behaviors. This cluster covers 98 papers. Representative work includes Modeling Deontic Modal Logic in the SCASP, Goal-Directed Predicate Answer Set Programming System, Formalizing the Binding Problem, and Conflict-Aware Seed Assignment in Classroom Environments. Trend 9 of 10, Theoretical Computer Science and Math. This trend explores foundational mathematical and computational problems, spanning complexity theory, analysis, logic, and probability. This cluster covers 72 papers. Representative work includes The Growth in D Constant is less than pi2 open parenthesis 1 plus 2 close parenthesis minus 10 minus 5. Planar perfect matching counting is as hard as determinants, and a remark on the majorizing measures theorem for general processes. Trend 10 of 10, AI Principles and Cognitive Insights. uncovering foundational AI principles and cognitive mechanisms underlying intelligent system behavior. This cluster covers 72 papers. Representative work includes neuron populations exhibit divergent selectivity with scale, symmetry-compatible principle for optimizer design, embeddings, LM heads, SWE-GLU MLPs, and MO routers, and language models compare quantities using number-specific and unit-specific heuristics. Up next, our first paper out of 10, Language Models Need Sleep. Learning to Self-Modify and Consolidate Memories by Ali Barouz and Vahab Marakni. This paper was selected because it introduces a profoundly novel and biologically inspired paradigm for large language models, LLMs, to achieve continual learning and memory consolidation, directly addressing a critical and pressing limitation in. Let's break down its key contributions. Contribution 1. Sleep Paradigm for LLM Continual Learning. A novel sleep paradigm was introduced, enabling large language models, LLMs, to continually learn and transfer temporal in-context knowledge into long-term parameters. This paradigm comprises two stages: memory consolidation, knowledge seeding, and dreaming, which together distill short-term memories into stable knowledge and facilitate recursive self-improvement. This approach addresses the inherent static nature of deployed LLMs, mitigating knowledge obsolescence and the catastrophic forgetting often seen with traditional continual updates. Contribution 2. Generalized distillation for knowledge seeding. A new generalized distillation process was developed for knowledge seeding, serving as the memory consolidation stage within the sleep paradigm. This process performs upward distillation by combining on-policy distillation with reinforcement learning, RL, based imitation learning to transfer memories from a smaller self-network to a larger network. This mechanism provides increased model capacity while preserving knowledge and effectively transforming fragile short-term memories into stable long-term knowledge, thereby preventing catastrophic forgetting. Contribution 3. RL-driven dreaming for self-improvement. The dreaming phase was introduced as a self-improvement mechanism for LLMs within the proposed sleep paradigm. In this phase, the model employs reinforcement learning, RL, to generate a curriculum of synthetic data, which is then used to rehearse newly acquired knowledge and refine existing capabilities. This enables recursive self-improvement and adaptation without requiring human supervision, allowing LLMs to overcome their knowledge cutoff limitations and continually evolve beyond their initial deployment. Up next, our second paper out of 10, AI Agents Enable Adaptive Computer Worms by Jonas Guan and Nicholas Papernot from University of Toronto. This paper was selected because it introduces a fundamentally new and highly adaptive class of computer worm enabled by AI agents, representing a significant and immediate advancement in the cybersecurity threat landscape. Let's break down its key contributions. Contribution 1. AI-powered adaptive worm demonstrated. An AI agent-enabled worm was demonstrated, capable of generating tailored attack strategies for each target encountered. The worm parasitically uses compromised machines to run open-weight large language models, LLMs, sustaining its reasoning and extending its reach across Linux, Windows, and IoT devices. This proves that self-sustaining AI-driven cyber threats are no longer theoretical, fundamentally differing from traditional worms that exploit predetermined vulnerabilities. Contribution 2. Economic asymmetry of AI worms. A destabilizing economic asymmetry was identified, where the attacker's marginal cost per new infection is zero. The worm operates by leveraging stolen compute from already compromised machines, eliminating the need for the attacker to provision additional resources for subsequent infections. This creates a significant advantage for attackers, as defenders face continuous costs for patching and monitoring, unlike the fixed costs associated with traditional malware. Contribution 3. Bypass of centralized AI controls. It was shown that centralized safety controls are structurally irrelevant for this new class of AI-driven cyber threats. The worm requires no commercial AI platform, instead utilizing open-weight LLMs executed directly on compromised infrastructure. This bypasses traditional defense mechanisms such as service refusals or rate limiting that rely on controlling access to commercial AI services, posing a novel challenge for cybersecurity. Contribution 4. Autonomous generative adversaries defined. The concept of autonomous generative adversaries was introduced and demonstrated as a new class of cyber threat. These malware systems propagate without human operators and are defined by their capacity to reason about targets, adapt to observations, and synthesize attack logic in real time. This represents a paradigm shift from fixed exploit code to dynamic, intelligent, and self-evolving malware, requiring new defensive strategies. Up next, our third paper out of 10. Can local learning match self-supervised backpropagation? By Wu S. Zihan and Guillaume Bellec from School of Computer and Communication Sciences and School of Life Sciences, EPFL, Lausanne, Switzerland. This paper was selected because it addresses a foundational theoretical question in deep learning by identifying conditions under which local self-supervised learning can match the performance of global backpropagation, which could lead to new, more biologically plausible, and let's break down its key contributions. Contribution 1. Local SSL Theory for Linear Networks. A theory was developed for deep linear networks that identifies specific conditions under which local SSL algorithms can implement the exact same weight update as global BPSSL. This theoretical framework precisely defines the architectural and algorithmic requirements for local learning rules, such as forward-forward or clap, to perfectly mimic the gradient descent steps of backpropagation in linear models. This establishes a foundational theoretical link between local and global learning rules, providing a formal guarantee for the equivalence of their weight updates under specific conditions, which was previously lacking for self-supervised learning. Contribution 2. Novel local SSL for nonlinear CNNs. Novel variants of local SSL algorithms were developed to effectively approximate global BPSSL in deep nonlinear convolutional neural networks. These variants leverage theoretical insights from deep linear networks and adapt them to handle the complexities of nonlinear activations and convolutional layers, aiming to improve the similarity of their gradient updates to those of global BPSSL. This extends the practical applicability of local learning principles from simplified theoretical models to complex, real-world deep neural networks, addressing a major challenge in developing biologically plausible learning algorithms. Contribution 3. Gradient similarity improves performance. An empirical correlation was discovered, showing that local SSL variants with higher gradient update similarity to global BPSSL achieve better performance on image datasets. This was demonstrated by evaluating various local SSL rules on SAFAR, TIN, STL, TIN, and TinyImageNet, where improved alignment between local and global gradients consistently led to superior representation learning. This provides a crucial design principle and empirical validation for developing effective local SSL algorithms, suggesting that maximizing gradient alignment is key to bridging the performance gap with backpropagation. Contribution 4. Local SSL matches global BP performance. The best local SSL rule, utilizing the clap loss function, match the performance of comparable global BPSSL with InfoNCE or CPSA-like loss functions and surpass the state-of-the-art for local SSL. This achievement resulted from combining the clap loss with the novel local SSL variants specifically designed to approximate global BPSSL gradients in deep nonlinear CNNs. This significantly closes the performance gap between local SSL and global BPSSL on standard image benchmarks like SAFAR, TIN, STL, TIN, and TinyImageNet, demonstrating the practical viability of local learning for self-supervised representation learning. Up next, our fourth paper out of 10, Overlaying Governance, a compositional authorization framework for delegation and scope in Agentic AI by Amjad Ibrahim and Yong Li from Huawei Heisenberg Research Center. This paper was selected because it addresses a foundational and increasingly urgent problem of governance and authorization for autonomous agentic AI systems, which is critical for their safe and reliable deployment in real dash. Let's break down its key contributions. Contribution 1. Agentic AI Authorization Framework. A compositional governance framework is introduced, providing primitives for authorization in agentic AI systems. This framework defines types of delegation and their accountability implications, alongside resource scope attenuation to bound agent access. It addresses the limitations of traditional IAM by enabling recursive delegation, contextual boundaries, and dynamic scoping, offering a formal yet practical foundation. Contribution 2. Policy Compositional Operator. A compositional operator is defined to integrate new agentic semantics into existing authorization domains. This operator overlays agentic semantics, such as recursive delegation chains, onto existing relational policies without requiring their rewriting. The operator enables seamless extension of current authorization infrastructure to govern agentic AI, enhancing practicality and adaptability. Contribution 3. Resource Scope Attenuation. The framework introduces resource scope attenuation as a primitive to precisely bound agentic access envelopes. This mechanism dynamically limits the scope of permissions an agent can exercise, enforcing contextual boundaries and preventing overprivileging. It provides crucial fine-grained control over agent actions, addressing the lack of dynamic scoping in traditional systems and improving accountability for autonomous agents. Up next, our fifth paper out of 10, Physics-Informed Diffusion Models in Spectral Space by Davide Gallen and Arnulf Jensen from University of Munster. This paper was selected because it introduces a highly novel methodology, physics-informed spectral diffusion, PSD, which synergistically combines generative latent diffusion models with physics-informed machine learning to address the pressing and. Let's break down its key contributions. Contribution 1. Spectral latent diffusion for PDEs. PSD learns the joint distribution of PDE parameters and solutions through a diffusion process operating in a latent space of scaled spectral representations. In this latent space, Gaussian noise corresponds to functions exhibiting controlled regularity, with scaling derived from the underlying data distribution. This spectral formulation provides significant dimensionality reduction compared to grid-based diffusion models and ensures PDE operators remain well-defined in the induced function space. Contribution 2. Physics-informed inference with ATOM. PSD enforces physics-informed constraints and measurement conditions directly during its inference procedure. This enforcement is accomplished by applying ATOM-based updates at every diffusion step, leveraging principles from diffusion posterior sampling. The method effectively addresses ill-posed forward and inverse PDE problems by regularizing the posterior distribution, particularly when dealing with sparse observations. Contribution 3. Superior performance on diverse PDEs. PSD achieves improved accuracy and computational efficiency when solving a range of partial differential equations. The approach was thoroughly evaluated on Poisson, Helmholtz, and incompressible Navier-Stokes equations. PSD outperforms existing diffusion-based PDE solvers, which are considered state-of-the-art for scenarios involving sparse observations. Up next, our sixth paper out of 10, Learning Without Training. The Implicit Dynamics of In-Context Learning by Benoit Darin and Javier Gonzalvo from Google Research. This paper was selected because it provides a mechanistic explanation for in-context learning, a fundamental and previously mysterious capability of large language models, significantly advancing our theoretical understanding of how these models operate. Let's break down its key contributions. Contribution 1. Implicit MLP weight modification. A transformer block implicitly modifies the weights of its MLP layer based on the provided context. This occurs through the stacking of a self-attention layer with an MLP, where the self-attention mechanism processes the contextual information. This mechanism helps explain how large language models achieve in-context learning capabilities without explicit weight updates, even for patterns not seen during training. Contribution 2. Contextual forward pass equivalence. A standard forward pass with context is mathematically equivalent to a forward pass without context but with updated MLP weights. The implicit update to the MLP weights is a minimal low-rank update that specifically represents the context provided in the prompt. This provides a formal mathematical understanding of in-context learning, demonstrating how contextual information directly translates into an effective modification of model parameters. Contribution 3. Contextual block generalization. The concept of a contextual block was introduced, generalizing the transformer block to explain implicit weight updates. This generalized block, when stacked with standard neural networks, implicitly transforms contextual information into a weight update for the first layer of the subsequent network. This offers a broader theoretical framework for understanding how contextual properties lead to implicit weight modifications in neural architectures, extending beyond specific transformer components. Up next, our seventh paper out of 10, One Thread Can Keep a PRNG Secret, but Not To by Ehud Porat and Benny Pincus from Independent Researcher. This paper was selected because it presents a novel and practical cryptanalytic attack on a widely used pseudo-random number generator in Apple's XNU kernel, demonstrating a critical security vulnerability with broad implications for cybersecurity. Let's break down its key contributions. Contribution 1. Race Condition Cryptanalytic Attack. A novel, practical cryptanalytic attack was developed against the IPv6 fragment ID generation algorithm in Apple's XNU kernel. The attack exploits a race condition vulnerability in the PRNG to learn its internal state, enabling prediction of fragment IDs. This represents the first cryptanalytic attack known to be based on exploiting race conditions, enabling IPv6 fragment spoofing and manipulation of network traffic. Contribution 2. Practical IPv6 fragment spoofing attacks. The ability to predict IPv6 fragment IDs facilitates IPv6 fragment spoofing, enabling partial manipulation of UDP datagrams or TCP segments. By predicting fragment IDs after exploiting the PRNG race condition, an off-path attacker can inject or modify specific fragments within a larger data stream. This enables new attack types, such as an off-path attacker modifying a file during NFS, UDP, writes, or altering an HTTP, TCP request. Contribution 3. XNU IPv6 PRNG Vulnerability Disclosure. A race condition vulnerability in the XNU kernel's PRNG for IPv6 fragment ID generation was discovered and assigned CV 2024-27823. The vulnerability arises from improper handling of PRNG state across concurrent operations, allowing an attacker to deduce future fragment IDs. Apple patched all its XNU-based products against this attack, highlighting the critical security implications for macOS and iOS devices. Up next, our 8th paper out of 10, toward training superintelligent software agents through self-play SWE-RL by Yuxiang Wei and Saito Wang from University of Illinois Urbana-Champaign. This paper was selected because it proposes a foundational step towards training superintelligent software agents through self-play, addressing the critical and pressing problem of overcoming human knowledge dependency in AI development, which has immense. Let's break down its key contributions. Contribution 1. Self-play SWE-RL, SSR, framework. The paper introduces self-play SWE-RL, SSR, a novel training paradigm for software agents. A single LLM agent is trained using reinforcement learning in a self-play setting to iteratively inject and repair software bugs of increasing complexity, with bugs formally specified by test patches and requiring only sandboxed repositories. This approach makes minimal data assumptions, overcoming the human data dependency of prior methods and enabling agents to autonomously gather extensive learning experiences for superintelligent systems. Contribution 2. Superior performance and generalization. SSR demonstrates significant self-improvement on standard benchmarks, achieving plus 10.4 points on SWE Bench Verified and plus 7.8 points on SWE Bench Pro. The agent's self-play training, where it generates and fixes its own bugs defined by test patches, allows it to learn robust problem-solving strategies and consistently outperforms the human data baseline. This shows that self-supervised learning without human-curated issues can lead to superior performance and generalize effectively to natural language bug descriptions, suggesting a path beyond human limitations in software development. Contribution 3. Autonomous bug generation via test patches. SSR implements an autonomous mechanism for bug generation and repair, where bugs are formally specified by test patches rather than natural language descriptions. The agent itself proposes test suite improvements that define a bug, then attempts to fix it, learning from the reinforcement signal of successful repairs. This mechanism eliminates the reliance on human-curated issues and test cases, enabling agents to discover and solve novel problems independently, which is crucial for developing superintelligent software agents. Up next, our 9th paper out of 10, TitanCA, Lessons from Orchestrating LLM Agents to Discover 100-plus CVEs by Ting Zhang and Wenbin Liao from Monash University. This paper was selected because it demonstrates a highly impactful and practical application of orchestrating LLM agents to address the pressing problem of software vulnerabilities, yielding significant real-world results with over 100 discovered CVEs. Let's break down its key contributions. Contribution 1. Orchestrated LLM Agent Pipeline. TitanCA developed a unified vulnerability discovery pipeline by orchestrating multiple LLM-powered agents. This system integrates distinct LLM agents across a 4-module architecture to systematically analyze code. It addresses the limitations of traditional static application security testing (SAST) tools, which suffer from high false positive rates and struggle with modern code bases. Contribution 2. High-efficacy zero-day discovery. TitanCA achieved the discovery of 203 confirmed zero-day vulnerabilities and yielded 118 common vulnerabilities and exposures (CVEs). The orchestrated LLM agents systematically identified and validated security flaws within open-source software projects. This demonstrates a significant real-world impact by proactively identifying critical software vulnerabilities before exploitation, surpassing prior detection methods. Contribution 3. Structured 4-module architecture. A 4-module architecture for LLM-based vulnerability discovery is introduced, comprising matching, filtering, inspection, and adaptation stages. Each module employs specialized LLM agents to perform specific tasks, such as identifying patterns, reducing noise, analyzing code, and refining strategies. This structured approach provides a robust and scalable framework for deploying LLM agents in security analysis, offering a more systematic alternative to less organized research. Up next, our 10th paper out of 10, The Deliberative Illusion, Diagnosing Factual Attrition and Stance Homogenization in Multi-Agent LLM Deliberation by Herwin Wan and Min Yin, Can from Xi'an Jiaotong University. This paper was selected because it identifies a critical and counterintuitive failure mode in multi-agent LLM deliberation, challenging the assumption that consensus always leads to better outcomes, which is a fundamental insight. Let's break down its key contributions. Contribution 1. Diagnosing Deliberative Illusion. The deliberative illusion was identified, characterized by factual attrition and stance homogenization, where multi-agent discussion erases up to 72% of issue-critical facts. This illusion describes the progressive loss of issue-critical facts and the collapse of diverse positions toward consensus during multi-agent LLM deliberation. This reveals a critical risk where agents achieve agreement while simultaneously losing essential information, challenging the assumption that consensus signifies successful interaction. Contribution 2. Delibtrace Framework Introduction. Delibtrace, a novel framework, was introduced to diagnose factual attrition and stance homogenization in multi-agent LLM systems. Delibtrace operates by decomposing issues into atomic facts, labeling issue-critical ones, distributing them among agents, and tracking their survival through discussion rounds. This framework offers a precise method to evaluate the reliability of multi-agent LLM interactions by focusing on information preservation rather than mere consensus. Contribution 3. Empirical Attrition and Homogenization. Empirical evidence demonstrated significant factual attrition and stance homogenization in multi-agent LLM deliberation, with up to 72% of issue-critical facts being erased. Experiments using 3 representative LLM families on ethical and news-based deliberation tasks revealed a consistent pattern of fact loss and convergence of diverse stances. This loss is consequential, as retained evidence can misleadingly reconstruct issues. Final stances remain anchored in base model priors, and a malicious agent can inject misinformation into the shrinking shared context. That's all for today's ArXiv Computer Science Daily. If you found this helpful, please like, leave a comment, and subscribe for daily paper summaries. See you tomorrow.